Intro to James Webb's latest image. One of the leading and most respected physicists of today has recently shared his thoughts on a breakthrough discovery. Michio Kaku, widely known for his exceptional contributions to the world of physics, has confirmed that the James Webb Space Telescope has made the astonishing find of 6 massive galaxies, which were previously believed to be impossible. This discovery holds the potential to significantly expand our understanding of the universe, making it an exciting development to monitor closely. Kaku, a renowned figure in the scientific community, is of both American and Japanese descent and is an expert in classical experimental physics and quantum mechanics. Unlike more cautious and skeptical scientists, Kaku is open to the extraordinary findings of the James Webb Space Telescope. His willingness to embrace these findings brings a refreshing perspective to the conversation, and we're thrilled that such an eminent scientist has decided to speak out, sharing what is now undeniable. The enthusiasm and even amusement in Kaku's tone are evident as he talks about the discoveries made by the James Webb Space Telescope. He sees it as a highlight of recent times, sparking his deep interest in the field. Join us as we delve into the implications of Kaku's view on the significance of these 6 colossal galaxies discovered by the telescope. Michio Kaku's first impressions. Kaku has always been a scientist who is open to exploring new theories and ideas, as he recognizes that Einstein's theory of relativity and Newton's laws alone cannot fully explain the complexities of the universe. Kaku believes that the findings of the new telescope have the capacity to significantly enhance our scientific understanding, even though many of his peers remain reluctant to accept this perspective. This hesitance has sparked concerns and debates among proponents and critics of the Big Bang Theory, as well as those who support or oppose quantum mechanics. Despite these reactions, Kaku remains unfazed, often finding humor in the skepticism surrounding the new discoveries. The James Webb Space Telescope's revelation of 6 enormous galaxies, dating back to the earliest moments of the universe, has stunned astronomers. These galaxies contain far more stars than our Milky Way, despite having formed only 700 million years after the Big Bang. The team of astronomers who made this groundbreaking discovery has coined the term universe breakers for these exceptional galaxies, as their existence could dramatically alter our entire comprehension of the cosmos. The new findings challenge the established understanding of the universe's origins. The Big Bang Theory suggests that immediately after the initial explosion, the universe was in a chaotic and hot state, with the first solid structures taking hundreds of thousands of years to form. It was assumed that galaxies, as highly organized structures, formed much later. However, some of the newly discovered galaxies are more massive than the Milky Way, and their enormous luminosity suggests they were rapidly forming stars, perhaps hundreds per year, whereas our galaxy forms stars more sporadically. The precise moment when the first galaxies emerged remains unclear. So far, research has been unable to determine this, but it is widely believed that initially only isolated stars or small groups of stars existed, gradually merging to form larger and larger accretions, eventually evolving into dwarf galaxies. Over time, these smaller galaxies collided with others, growing in size. According to previous models, such large and complex galaxies could not have existed so early in the universe's history. This raises the intriguing possibility that the universe may be much older than previously thought, or that complex galactic formations developed much earlier than anticipated. However, this theory remains difficult for more traditional scientists to accept, and some factions of physics still reject this discovery, questioning the accuracy of the age estimates. Kaku, fully aware of these challenges, remarked that many outdated and inaccurate theories continue to persist due to the prestige of certain scientists. These outdated models were only discredited once key experiments revealed their flaws. Therefore, the foundation of science, particularly in the field of physics, lies with experimentalists who hold theorists accountable. In fact, when it comes to understanding the true beginnings of the cosmos, humanity knows very little. The Big Bang Theory and the Evolving Understanding. The Big Bang Theory was proposed in 1927, based on observations of the expanding universe. These observations suggested that the universe originated from a singular point and has been expanding ever since. At that time, the concept of a universe with a beginning and an end was nearly impossible for people to grasp, as the idea of a universe that had always existed seemed inconceivable. Even today, scientists continue to struggle with fully understanding the universe's true nature. However, the latest discoveries, while seemingly contradicting the Big Bang Theory, should be considered with an open mind. Science has shown repeatedly that progress often comes from reevaluating old ideas. The confirmation of new theories and discoveries is an essential part of the scientific process. For instance, when Einstein was a child, people believed that the stars and planets were stationary, occupying specific places in the cosmos. Now we know that everything in the universe is in motion. Planets orbit stars, stars move within galaxies at incredible speeds, and entire galaxies are hurtling through space at remarkable velocities. Their ultimate fate still uncertain, today's scientists are faced with the challenge of accepting uncomfortable truths, realizing that theories are not absolute and must undergo rigorous testing before they can be considered valid. How this changes our view of the universe. The Big Bang Theory emerged from the observation that galaxies are moving away from each other, with the speed of separation proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe had been expanding for quite some time. Further supporting evidence came from elements such as cosmic background radiation and the red shift of light from distant galaxies. However, it is crucial to remember that in the past, people also held incorrect beliefs, such as the idea that the Earth was flat or that the Sun revolved around us, beliefs that were supported by the evidence available at the time. It wasn't until later technological advancements provided a clearer and more accurate view that these assumptions were debunked. We are now in a similar situation, where the expectations surrounding the James Webb Space Telescope have not been met with confirmation of the Big Bang, but instead with the discovery of these 6 galaxies, which seemed impossible. This development serves as a reminder that science is constantly evolving, and researchers must remain open to new findings, reassessing existing theories in light of fresh evidence. Redshift and its role. Redshift, a tool used by researchers to measure quantities in cosmology, provides insights into the motion of celestial bodies. It refers to the change in the wavelength of light as the source of the light moves relative to the observer. For example, when a car approaches, the sound of its engine grows louder, but as it moves away, the sound fades. This principle also applies to light. When a light source moves toward an observer, the light shifts toward the blue end of the spectrum, and when it moves away, the light shifts toward the red. This phenomenon, known as redshift, has been used to calculate the velocities and distances of celestial objects. However, small errors in these measurements could significantly impact results, prompting a reevaluation of measurement techniques. It remains to be seen whether the revised data will reveal the recent discoveries related to our universe, necessitating a thorough examination to determine whether errors in redshift measurements are responsible or whether some scientists are simply refusing to acknowledge the facts. This is an important question that requires careful analysis and a review of the methods and data involved. Expert opinions on the discovery. As we continue to explore the depths of the universe, it's clear that the scientific landscape is shifting. The discovery of the 6 massive galaxies challenges long-held assumptions about the universe's timeline and formation. Traditional cosmology, which is centered around the Big Bang Theory, has been the dominant framework for understanding the origins of the cosmos. The idea that such large galaxies could have formed so soon after the Big Bang upends the established narrative and invites us to reconsider many aspects of cosmic evolution. For years, researchers have been working within the framework that after the Big Bang, the universe was in a hot and chaotic state. Over time, it cooled down enough for the first atoms and structures to form. The prevailing theory suggested that galaxies, which are highly structured and massive, could not have appeared early in the universe's history. But the discovery of these galaxies challenges this assumption, posing a major question. Could the universe be older than previously thought, or perhaps complex structures, like galaxies, began to form much earlier than we believed? Final thoughts, and the future of space exploration. This new revelation is not just curiosity. It could have profound implications for our understanding of everything from the fundamental laws of physics to the structure of the universe itself. Some scientists have argued that the speed at which these galaxies formed and their size challenges current models of galaxy evolution. Our current understanding suggests that galaxies formed over billions of years, gradually coalescing from smaller groups of stars and gas. The idea that such vast and luminous galaxies could have formed in the first few 100 million years after the Big Bang is perplexing. This revelation raises a potential paradox. How could such massive and highly organized galaxies form so quickly in a universe that, according to the Big Bang theory, should have been in a much less stable and ordered state? While many researchers are still cautious about this discovery, others are embracing it as an opportunity to reevaluate long-standing assumptions. Kaku himself has pointed out that science is an ever-evolving field, where new discoveries can challenge and even overturn previous theories. He noted that history is full of examples where old ideas, once thought to be irrefutable, were eventually proven wrong. For instance, the theory of a geocentric universe was widely accepted for centuries, only to be replaced by the heliocentric model. Similarly, the discovery of the 6 galaxies by the James Webb Space Telescope could eventually lead to a major shift in our understanding of the cosmos. Outro, and stay tuned for more. In his remarks, Kaku emphasizes the importance of embracing new ideas and remaining open to revising old theories. The role of experimental science, particularly in physics, is critical in this process. It is the work of experimentalists that keeps theoretical science grounded in reality. New discoveries, like the detection of these galaxies, challenge existing models, prompting scientists to reconsider their assumptions and adjust their theories accordingly. While many may resist this paradigm shift, Kaku's optimism and openness to change serve as a reminder of the dynamic nature of scientific progress.